Hello, we're Group 7, and the team will be analyzing the control of an adaptive variable suspension system. The team members include Laura, Lusana, Bujin, Vasu, and Luis.
In this presentation, we will discuss our research background information on automobile suspension, motivations, objectives, MATLAB calculations, Simulink setup and analyzer analysis, and the results.
For as long as vehicles have been on the road, suspension systems have been evolving. Current suspension setups play a key role in driver and passenger safety, vehicle stability, and the reduction in noise and vibration harshness. Suspension components are engineered to keep all four wheels of a car on the ground in order to maximize friction between the tires and the road. Any loss of friction inevitably leads to the loss of vehicle control. Ideal suspension designs focus on reducing as much vibration harshness as possible. An active suspension system can adjust itself continuously to changing road conditions. Active suspension systems consist of the following components: a computer, adjustable shocks, a series of sensors at each wheel and throughout the car, an actuator or servo atop each shock. These components may vary slightly from manufacturer to manufacturer, but these are the basic parts that make up an active suspension system.
The team will be developing and analyzing the suspension of a vehicle, all while always having safety in mind. The team aims to increase the efficiency of the suspension maintenance in the vehicle, and the team will simulate the suspension control system using MathWorks, MATLAB, and Simulink and Senscape. For instance, the active control system will calculate and recognize the wear and tear from cyclical usage and notify the driver to replace the suspension components. Therefore, the vehicle will be operating at an optimal performance, alerting signal that will notify the driver when and if there's a suspension failure and gives a warning beforehand, which is most importantly will keep the driver and the passengers safe.
To analyze and understand an active suspension system using MATLAB, Senscape, and Simulink, the team must compare the frequency generated in suspension with time of part in the car to understand its longevity, understand a time frequency analysis of the vehicle to suspension to implement system alerts for suspension maintenance with varying conditions such as mass, stiffness, and damping force. The maintenance keeps the driver safe and consumer and ensures a proper part in the vehicle to avoid catastrophic failures of suspension. In the CAD simulations, as you can see, our goal is to design an ideal system where the wheels and the suspensions are moving, but the body of the car is being as stable as possible, while the road's conditions may vary and bumps and bruises may occur, but the car body has to remain stable compared to the conditions of the road.
Now, the Simulink setup takes into consideration a few aspects of the suspension. It'll be the tires and the shock absorber and spring. Each component plays a key role in the vehicle's stability and comfort. Simulink will be set up to help better understand how these components will interact and how new systems will be implemented. Also improve the life of the vehicle, also the comfort of the passengers. The inputs for the system can be found in the appendix along with the sources used for calculations.
As you can see in the input of the Simulink that was developed, we can see the tire positions continuously to vary while the road conditions may change, but the body of the car, of the vehicle itself, is actually much more stable condition, as you can see from the graph. And that is what we were trying to generate from the use of our CAD model into the MATLAB and Simulink.
And here, as you can see from the results, the amplitude is the highest at the initial excitement force on the system and shows the reduction of amplitude over time. This illustrates that the system is under damped, and also it means that it is stable. To further analyze, the first max overshoot occurs at around 4 seconds, and the second max overshoot occurs at around 12 seconds. So in a passenger's point of view, the ride will be more comfortable overall. Vibration will reduce the bumps and in the ride in a short period of time with a small oscillation.
Potential issues can and will arise with this type of system. There are specific plans on how to mitigate these potential issues. If damage to suspension components occur, the plan will be to determine harmonic frequency to understand the failure point in the active suspension system. If there is a premature failure of the springs and bushings due to improper damping, then the plan will be to add sensor to monitor the shock absorber life and spring compression cycles. This will allow the sensor to detect the angle of the vehicle control arms. These are our references.
Thank you.
Thank you.